Hello again, 8th graders. This is Chapter 5.9a, Trig Ratios. One of the places in which we use ratios is in our study of right triangles, which is a branch of mathematics known as trigonometry. First of all, for some background knowledge, two right triangles with congruent angles are considered similar. This means that their sides should be and are proportional. The ratios involving the lengths of the sides have specific names, and this only works for right triangles. These ratios of the lengths of the sides of a right triangle are called the trigonometric ratios or trig ratios. Perhaps you've looked at your calculator and you've wondered why it says sin, cos, and tan on it, since you really don't want your calculator to sin, and of course it doesn't make any sense to look at tan on a calculator. Those really refer to the sine, the cosine, and the tangent. The sine of an angle, such as angle A, is found by taking the length of the opposite leg, which in this case would be line segment BC, over the length of the hypotenuse, which is line segment AB. The cosine of A is found by taking the length of the adjacent leg, which in this case is AC, over the length of the hypotenuse, which would be AB. The tangent is found by taking the opposite length, which is BC, over the adjacent, which would be AC. We often use a particular device, like a mnemonic device, in order to remember this, and it's called SOHCAHTOA. SOHCAHTOA. The S means opposite over hypotenuse. The C for the cosine means you take the adjacent over the hypotenuse. And the T for tangent means we take the opposite over the adjacent. And if you write that down, if you memorize it, write it at the top of your paper, it comes in pretty handy. SOHCAHTOA. Let's get right to it. We are going to find the sine ratios, or the trig ratios rather, for this triangle. And I would just remind you that it is SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. We're going to start by finding the sine of angle G. Now, opposite and adjacent are going to change based on what angle I'm looking at. So I'm first going to look at the sine of angle G. That's going to be opposite over hypotenuse. If I'm at angle G, my opposite is 48. The hypotenuse is always across from the right angle, so that's going to be 52. And then I reduce them to lowest terms. Dividing by 4, I will get 12 over 13. Okay. Now, I'm still working with angle G, and this time I want to work with the cosine, CAH, C-A-H, so that means I need the adjacent over the hypotenuse. The adjacent is going to be right here. So that's 20 over the hypotenuse of 52. Again, I can divide both of those by 4, and I will get 5 over 13. Now for the tangent, I'm going to want the opposite over the adjacent. Remember, our opposite is here. This is our adjacent. So I want the opposite, which is 48, over the adjacent, which is 20. And I'm going to reduce that to 12 over 5. And at this point, that's where they want you to leave it, is 12 over 5. Now, here's where it gets a little sticky. In the next part of this, I want the sine of angle H, which is over here. Now here's my right angle, so this is still the hypotenuse. But if I'm working with angle H, the 20 becomes opposite. The 48 becomes the adjacent. So we have to be careful. We always need to change our reference depending upon what angle we're working on. Now based on SOHCAHTOA, I'm going to take opposite over hypotenuse. And my opposite here is going to be 20 over 52, which reduces to 5 over 13. Now, we try and do the cosine. All right, we need to take adjacent over hypotenuse, which in this case is going to be 48 over 52. So that's going to become 12 over 13. Again, you try tangent. The tangent is equal to, remember that's TOA, OA, opposite over adjacent. I'm kind of out of room there, so I'll work downwards. 20 over 48, and that reduces to 5/12. Could I find the sine, the cosine, and the tangent of 90 degrees? Yes, but to be honest with you, we just memorize them. The sine of a 90-degree angle is 1, the cosine 0. We really don't have a tangent for a 90-degree angle. It's considered undefined. Okay, now, I forgot to put something in here. We are only going to be finding the sine of x and the cosine of x. But in order to do that, we do not know our hypotenuse here. So I am going to have to use, you are going to have to use the Pythagorean theorem in order to find that hypotenuse before you can find the sine of x and the cosine of x. So we're going to start with a squared plus b squared equals c squared. 9 squared plus 12 squared equals c squared. 81 plus 144 equals c squared. So c squared is going to be 225, and c equals the square root of 225, which should be 15, and we do need a label here. They don't tell us if it's feet or inches, so we're back to units. Okay, we are going to work with angle x. Now here's our hypotenuse. We have found out that it's 15. This is my opposite. This side is my adjacent. Now remember, again, we're working with that SOHCAHTOA. So if I want the sine of x, I'm going to have to use the opposite, which is 9, over the hypotenuse, which is 15, and then reduce it to 3 over 5. To find the cosine of x, I'm going to take the adjacent, which is 12, over the hypotenuse, which is 15, and then I'm going to get 4 over 5. All right. Now, you should remember how to do the Pythagorean theorem from a prior chapter. Notice you're finding a leg here. I would like you to hit pause. You do it. I'm going to actually do the work and then show you how it turns out. That is the work for example B. If you need to hit pause again and work on it, I would suggest you do so. Now we'll move on to the last part of what we're going to do, and this is where you're going to use your calculator. Now it's going to depend upon if you have a 30XA. There you have to put in the angle first and then press the sine button, and you don't usually need to press equals. You should, if you do that, try it, you should get 3420 when you round off, because we usually round to the nearest 10,000. Now the 30x Roman numeral 2s works a little differently. There you are going to push the sine button first, then the 20, and then you have to press equals and round off. But you should again get 0.3420. So if we do the sine of the 12-degree angle, you should get 0.2079. Let's try one more. So we're going to put in our cosine of 35 degrees. You should get 0.8192. At this point, hit pause, and I'll hit pause as well, and then you can start it up again to see the actual answers. And I hope that you came up with the same answers as our key here. And that concludes lesson 5.9a, Scouting Out.